Welcome to Docker Essentials for Building Cyber Labs. By the end of this session, you'll understand how Docker helps create isolated and repeatable cyber labs. You'll learn how to make a custom Docker network with static IPs, write a simple Docker file using the core commands from, run, copy, and expose, then build and run your container with specific options for naming and networking. We'll also verify that everything works correctly and go over a few quick troubleshooting tips. Finally, as a bonus, we'll practice upgrading a reverse shell by adding job control, spawning a Python sudo terminal, and setting up environment variables to make it fully interactive. A Docker image is a blueprint for creating containers. It's a read-only snapshot that contains everything your application needs to run, including the operating system, software, libraries, dependencies, configuration files, and your code. We use a Docker file to build the Docker image. A Docker file is a plain text script that contains a series of instructions describing how to build a Docker image. Let's jump into our lab and create our Docker file. I'm logged into Kali Linux, and this Kali Linux host is a VM. So we're going to run Docker on Kali. Now, Docker does not come installed by default on Kali. You can run Docker -- version to see if Docker is installed. Now, I've already installed Docker, but if it's not installed, you can use sudo apt get install Docker IO and Docker -compose. These are the two packages you need to build and run Docker containers. The next thing I'm going to do is create a directory for my lab. So I'm going to make a directory called RevShell Lab and cd into RevShell Lab. The next thing we need to do is create our Docker file. So I'm just going to use Vim to create a Docker file, and it's going to be Docker file with a capital D. Now that we have our Docker file, we can start building our Docker file so that it will create our Docker image. The first thing we're going to do is go into insert mode by pressing I, and then I'll type from, and then I'm going to give it a base image. Now for this lab, we're going to use a PHP distro that has Apache installed. So PHP colon 8.2 dash Apache. Next thing, we need to install Python. On this base image, Python's not installed by default, so we can use the run command to actually run commands on the image to install various packages or do other types of configurations. So let's go ahead and use run, and we're going to do apt get update. So the first thing we're going to do is update the repos, followed by ampersand. This means if this command succeeds, go ahead and execute the next command. Now I'm going to put this on multiple lines so we don't have one huge long line. So I'll use a backslash so I can go to the next line. If apt get update works, then we're going to do apt get install -y. Now -y allows us to install this without prompting for a continue, like, do you want to install this package, yes or no. So this will assume yes. So we'll use -y, and then we're going to use tac no install -recommends. By default, apt-get will install both dependencies and recommended packages. We're telling apt not to install recommends. We want the dependencies only. So we want to keep this image to the smallest size possible. And then we're going to type Python 3, which is the package we want to install. Now, if that succeeds, we'll go ahead and clean up the cache so that we can keep the size of this image as small as possible. So we'll use rm-rf/var/lib/apt/lists and then everything inside of that directory. The next thing we want to do is we're going to upload a PHP reverse shell onto this web server so that we can connect to it to practice upgrading our shell. So I'm going to use the copy command, which will copy something from a directory up to that image. So I'm going to copy from that slash, so current directory www slash. So everything in this current directory I want to copy up to the doc root on the web server, which is /var/www/html/. So all the contents of www go into the folder /var/www/html/. Finally, the last thing I need to do is I need to expose port 80 so that we can connect to the web server. So we'll use the expose command and then the port number, which is port 80. I'll go ahead and hit escape :WQ to write and quit. And now if I type ls, we have our Docker file. The next thing we need to do is go ahead and create our local copy www folder so that we can copy our PHP reverse shell up. So I'm going to make dir to create a directory www. Then I'm going to copy a reverse shell that comes with Kali. It lives in USR share web shells PHP php-reverse-shell.php, and I'm going to copy in to the www folder so that that's the reverse shell that gets copied up. And I'll go ahead and hit enter. Now I need to modify that reverse shell. So let's cd into www, and here's our reverse shell. I'm just going to take a look at it real quick. All right, you notice in this reverse shell there is a variable for the IP to connect back to and a port. So we're going to update these. But first, let me go grab the IP address I want to use. So I'm just going to do ifconfig grep inet so I can grab my IP address that I want to connect back to. And then I'll VI the PHP reverse shell. And I'm going to go ahead and go into insert mode by pressing I and Control-Shift-V to paste in the IP address, and then I'll pick a port. You can pick any port that you want. I'm going to use 777. I'll escape and go :WQ for write quit, and that PHP reverse shell should be ready to go. So I'm going to cat that just to make sure the changes took place, and I'm going to grep for IP. And you can see right here is our IP, so everything looks good. All right, now that we have that, we have our Docker file, we have the directory and reverse shell to copy up. Let's go back into the slides and take a look at what's next. So the next component is actually building a network. In a simple CyberLab context, a user-defined bridge network creates a private virtual LAN inside Docker. It lets containers communicate directly with each other while staying isolated from other parts of your system. The advantage is control. You can set up your own subnet, assign static IPs, and build predictable lab setups that behave like real-world networks. Even though it's private, your host machine can still reach all containers on that network, which makes testing, scanning, or interacting with them straightforward. This balance of isolation and accessibility makes user-defined bridge networks ideal for small cyber labs, penetration testing environments, and controlled training simulations. let's go ahead and walk through the steps of building our Docker image and then running it and verifying it. But first, we're going to create a network. So the first command I want to use is docker network create. So docker network create, and I'm going to give it a subnet. Let's fix this here. I'm going to give it a subnet and then a name. So I'm getting autocomplete here, so let me fix this real quick. So let me try to hit enter. So I'm going to use sudo. I need to use sudo to create this. Sudo docker network create. I'm going to give it a subnet followed by a name that we can attach to. So this is important to remember this name. We're going to use 172.28.00/16. That gives us an incredible amount of hosts, but you can use any network you want. You can do 192.168.1.0/24 or whatever subnet you want to create. This will work for us. All right, now that I have a network, the next thing I want to do is build my Docker image. Now, a Docker image is the template for spawning containers. So let's go ahead and build the Docker image. I'll use sudo docker build. We're going to give it a network. Instead of when I build it, I'm going to use network host because this will allow us to bypass any DNS errors. So use the host network when it reaches out to build this actual image. So I'm going to use network host, and then I'm going to give it a tag, and we're going to call it revshell-lab. And I'm going to use the current directory, but we need to change directory up one directory so we're where the Docker file is. So cd ... and then I'll use sudo docker build. We'll run this. It's going to build our image, and you can see it's reaching up and grabbing all the necessary components. All right, now that the image is built, we can check that the image is built. Sudo docker images. And you see we have this revshell-lab we just built. So we have the image that we need to actually run and spawn a Docker container. So the next thing we want to do is go ahead and spawn our container by using docker run. So sudo docker run -d means detach from the terminal and run it in the background. Then we're going to use --name to give it a tag. So we can call this revshell-lab. This is an easy to remember name so that we can reference the container itself, the instance. Then we're going to use --network to connect to a lab network, give it a static IP using --IP. We'll use 172.28.0.10. And this is the image that we want to build the container from. That matches our repository here. So once we hit enter, we now have a container. And I can do sudo docker ps To see that our container is running, we tagged it with revshell-lab. And now if I go to our browser here and go to 172.28 slash php dash reverse dash shell.php, we get some type of error here, and it's just telling us that that this reverse shell is unable to connect to our host 192.168.145.128, and that's just because we don't have a listener set up. So we're going to do some bonus content here and work through upgrading a reverse shell so that you can see how you can use a lab that you set up in Docker to do some practice work. When working with reverse shells or remote sessions, job control helps you manage background and foreground processes. You can suspend a running process with Control plus Z, list or resume it in the background using BG or FG to bring it back to the foreground. These controls make it easier to stabilize or modify a shell without losing your connection. To make a reverse shell fully interactive, we often spawn a pseudo terminal, sometimes referred to as PTY, using Python or other methods. And once we have this Python, we'll adjust the environment by adjusting environment variables such as the term and shell environment variables to make the reverse shell fully interactive. Here are the steps. The first thing we're going to do is make sure we're using a bash shell on the attacker host. That way that we can match up our shells. Now you don't have to use bash, you can probably use sh and it'll probably work just as well. We're then going to use Python to spawn a PTY session, followed by setting some environment variables, and then we'll background our shell and make it fully functional by using stty command to modify the raw to omit echoing characters, and then if we need to, we'll adjust the terminal rows and columns locally. Let's go ahead and jump back into our lab environment. Now I'm going to go ahead and open up another terminal here and create a reverse shell. So I'll use netcat-nvlp 7777 because that's the port that the reverse shell is going to connect back to. Now we're listening. But one thing I didn't do is check my shell. So let's close that and let's do echo $shell. That's an environment variable that tells you what your shell is set to by default, which is ZSH. But a more accurate way to do this is ps-p $$. $$ takes the PID of the current process here and passes it to this command, and you can see we are indeed in a ZSH shell. We want to change that to bash, so I'm just going to drop into a bash shell by typing bash, and we'll use ps-p $$ to take a look and make sure we're in a bash shell. Now we are. We can go ahead and start our listener by using netcat-nvlp 7777. Now we're listening. Let's go jump back here and refresh our reverse shell on our Docker container, and that should connect back to us, and we do have a connection. Now the first thing I want to point out is we can't access TTY. That is, and that's why we don't have an interactive terminal. So one thing we can do is use Python to create a pseudo terminal which simulates or acts like an interactive terminal. The next thing I want to point out is job control is turned off. Job control in Linux manages and allows us to run multiple processes in our terminal session, and it gives us control, allows us to background or resume or suspend various processes. Also, we can print out our shell here, so echo, and you see that is empty. We'll echo term, and our terminal type is also empty. So what I'm going to do is go ahead and suspend this process, push it into the background. To do that, I'll use Control Z. Now bash will say stopped. Other process or other terminals or shells may say suspended. And it's really just suspended. It's not really stopped. I guess they're the same, it's just semantics. But what we know is this is the job ID, this is the status, and here's the command that was used to start that process. I could type jobs to get that information at any given time. And if I had multiple processes running or stopped, they'll show up in this jobs queue or jobs list. Now that I have this stopped, I want to see what my term is set to. So I'm going to echo the term environment variable locally, and that's set to X-256 color. Let's copy this real quick, and we'll resume our session, and I'm going to pass foreground %1, and that brings me back into my reverse shell. Now I'm going to use the export command to set my term environment variable. Use Control Shift V to paste in what we copied and hit enter. And now we can use clear, right? So that'll allow us to clear now. The next thing we want to do is go ahead and use Python. Now let's type Python 3 -- version to make sure Python was installed. It is, and it's version 3.13.5. So we'll use Python 3-C double quote. First thing we'll do is import a library or module called PTY, which allows us to spawn other shells within our session. We'll use a semicolon, which allows us to put multiple commands, Python commands, on the same line. The next thing we'll do is do pty.spawn, and we're going to spawn a bash terminal. Now I need to use single quotes here because I opened the command with a double quote here. So single quote for the string within the command, we'll spawn /bin/bash, and then close that string with another single quote, close our call with the closing parenthesis, semicolon to close the statement, and double quote to close the actual Python command. And we'll go ahead and hit enter. Now notice that our prompt changed here and it looks more real like a normal terminal session. Now we're not all the way there yet. However, when we do run ls, we do have some formatting here. We're getting closer, but we do not have tab complete. If I try to cd to /home and use tab complete, it does not work. So what we need to do is background this reverse shell again by hitting Control Z. The next thing I want to do is go ahead and use STTY to actually remove echoing the characters back to the terminal. So I'll use STTY raw dash to remove echo. And then if that's successful, I'll use ampersand, then I'll just foreground my reverse shell by passing it $1, which is the ID of my job right here. So I'll go ahead and hit enter. Now the screen looks a little bit out of place. I can just type reset to get everything square. And now if I do cd/home, I can use tab complete. And if I just hit cd double tab, that lists all of the possibilities for changing. So we now have a fully interactive shell here and completed everything we needed to get done. Let's jump back into the slides and see how we can actually clean up. So for cleaning up Docker, there's going to be a few steps that we're going to do. We'll stop the running container, remove the container. Now just think of the container as a instance of the image. The image itself, we want to be able to restore back to the original image. Think of all the changes you'll make to your Docker container as you're working through it, right? And you're trying to, let's just say you're using Docker containers to practice penetration testing. So you're going to actually exploit that container, and that's going to cause changes and could lead to corruption of the actual container. So you want to be able to restore back to the image, and that's important. So after you remove the container, you might delete the custom network. That's kind of optional. You can leave it in place if you want to. And then you might delete the image if you want to clean everything up. Otherwise, you can keep that image there and just use that run command to spawn an instance of the container anytime you like. So let's go take a look at how we would do some cleanup. I'm going to go ahead and um, close this reverse shell and jump back to my other terminal session. So if I do sudo docker ps again, you can see that we have a container running. Now we can close this instance here by referencing either the name, that's why we tagged it with a short name, or we can use the container ID. So the first thing we want to do is sudo docker stop and pass it the tag name and hit enter. All right, and it stopped that container. Now if I do sudo docker ps, we can see that there's no containers running. Now that container is built, and if we want to remove it, we just do sudo docker rm reverse shell dash lab, which gets rid of that container. So that container could be corrupted, and we can just remove that container. Now that that container is removed, if we wanted to get rid of the network, we could do sudo docker network rm and pass the labnet. Now I'm going to leave my network here because I like to spawn this container up, and we'll use it for additional training. Once I'm done with it, I might pull down this network. And finally, if you want to remove the image, you can use sudo docker rmi and then the name of the image. Now remember, you can get the name of the image by using sudo docker images. This is the name of the image. For instance, I'll go ahead and remove this PHP lab one for demonstration purposes. Sudo docker rmi php lab. You can see untagged here and deleted. And now if I do sudo docker images, you can see the PHP lab is now gone. So that's how you clean up after yourself a little bit, keep your environment clean and usable. Lastly, I want to thank you for watching. I appreciate your time. And if this was helpful, I mean, please consider subscribing and hitting that like button. Also, if you have some colleagues or friends that might find this video useful, please take a moment and share it with them. All right, that's it for this video. Until the next one, have a good day.